Good evening, everyone. I just wanted to give a bit of an update on my progress with this home-built radio. A bit of what I've done so far, what I'm trying to achieve, and what's working and what isn't. So I'll start on the left here. We have a Arduino Pro Mini 5-volt here. Right now I'm just powering it off of the USB to TTL, FT. What's that? Anyway, that right there, we're powering the Pro Mini off of, and what we've got plugged into that Pro Mini is this here. I think it's called a 1602A LCD display. 2-line, and I think it's 16 characters across, so 2x16. It actually says on the back there. Oh, it's covered up. And then I actually had to buy the black board on the back here separately, and that's just an I2C board, which then drives the LCD display. Otherwise, I would need a lot more pins to drive it. I should have just bought them as one piece, but I didn't know what I was doing when I purchased it. So anyway. You can see there I've got on the display, I've got the frequency that I'm tuned to, my call sign, and what band I'm on, this is only a single band radio, so it's kind of redundant, but I've got a rotary coder in here which I use to control the display. So pushing in allows me to change the cursor position, and then rotating the knob changes the frequency. The code is Charlie Morris's. I'm sure he borrowed from other people as well. It took a bit of updating. Some of the libraries I had required me to call functions a bit differently. Anyway, so it's a bit different there. Over to the right here, I have a direct conversion receiver, which I just verified this evening is actually working. I had no idea whether or not it was working. For some reason, the 40 meter band seems really noisy. I was using my RTL SDR to just check conditions over the weekend, and it's been snowing a lot, and I don't know if that has anything to do with it, but there's just been a lot of noise and a lot of impulse noise, so like broadband noise coming in. So anyway, I haven't been able to test on real signals using my antenna. Granted, it's just a short antenna. It's just whatever came with my RTL SDR, but I've actually been able to pick up Morse on it in the past, so I know it's a good enough antenna for the purpose as a test. But anyway, so it's been difficult to test, but what I have here is my bandpass filter, which I discussed in a previous video and tested. The bandpass filter there, my low noise amplifier here. Well, it's not really a low noise amplifier. I guess you'd call it my receiver amplifier or whatever, antenna amplifier. That goes into a double balanced mixer. It's a diode ring, so you've got 41, 48 diodes here. A couple, what would you call them, tri-filler wound inductors or transformers. And then that goes over via this resistor here into my audio amp. And this thing here has been causing me a lot of problems. I've been getting a lot of like a buzz, like a 60 hertz buzz coming from the mains, which I don't understand because this is all powered off of a 12 volt battery. So it's just a bunch of AA's stacked together here. So I don't know why I'm getting the buzz, but it's obviously, 60 hertz is everywhere. I mean, my soldering iron runs off 60 hertz. I've got a power bar behind my monitor that runs off 60 hertz. So it's no surprise that I'm getting the buzz, but I don't know how other people deal with that buzz. So it was really bad. In fact, I was feeding in through here. I have got an audio cable just this thing here. So it's a couple wires. On the other end, I've got a jack, and I just plugged that into my phone, and I had a waveform generator on my phone. So I fed in some audio signals, and I was getting basically garbage out of my speaker. I was just getting this buzz, and I could faintly hear the other signal in the background. So what I ended up doing is inserting this 2200 microfarad capacitor on my power line, like between power and ground, and that seemed to reduce the buzz. However, the buzz is still there. So I'm going to power everything up, and you're going to see what I'm talking about here. So what I did, I had a lot of short circuit issues where cables were touching where they weren't. So I actually have a battery indicator here. So I'm at 11.4 volts. I don't know if you can see that. And if that drops really low, I know I've got a short somewhere. But right now it's just indicating that my batteries are not fully charged. So anyway, immediately you can hear that buzz. So if I crank up the volume here, it'll get worse. So that's full volume right there. That's just, I don't like that. I wish it was just, a hiss is fine, but that's a buzz. And I mean, I guess I could add more capacitance on my power supply lines, but there's got to be a more elegant solution than that. So I'm going to back off the volume there. Anyway, I wasn't able to verify that this was working until tonight. So the way I verified that it was working is I'm actually using two, because this is just a direct conversion receiver, I'm only using one mixer to mix down to audio frequency. So I have this here, which is doing the mixing. This is at whatever frequency is displayed here. So right now it's 7 megahertz. And this other one, this other output, clock 2, is going through a 20 dB attenuator. It's just a pi circuit with a couple, or 3 resistors rather, 1 in series and 2 shunted. I just found it online somewhere. So anyway, that's 20 dB attenuation. I'm driving clock 2 with 2 milliamps, which is I think 3 dB. Don't quote me on that, but it's the lowest drive level that's available with the libraries I'm using. This, on the other hand, is being driven with 8 milliamps. Anyway, but this is just like a test signal, and that's being fed through this white coax here into the input of my bandpass filter. So I've got this clock running at 7.023 megahertz, and that's just a test signal. So if I hear a tone at 7.023 megahertz, I know that my direct conversion receiver is working. At least it's working okay, even if it's not working great. So what I'm going to do here is just try and do this one-handed. I'm just going to start scrolling. And there we go. I don't have any filter, so even here, even though that's 10 kilohertz off, or 13 kilohertz away from my signal, I can hear it already because I'm not filtering. I don't have a crystal filter in here. It's just direct conversion. So I can already hear that. And the filtering I've got basically on my audio amp. I've got the input. I have a filter which filters out really high frequencies, but obviously not. It's still anything within the audible range you'll hear. And then on the output here, just to try and get rid of some of that 60 hertz noise, this capacitor on the output here will filter anything below 300 hertz. But anyway, you can hear that, if your ears are good enough, you can hear that really high-pitched whine already. And then if we go to 7.02, very noticeable. I'm going to turn down the volume here because it's hurting my ears. There we go. And now, if we tune right into 7.023, it'll actually go away because we'll be right on the carrier. There we go. It's quiet. So I said 300 hertz, you'll start to hear it now. Not quite yet. But if I go, it's not very noticeable yet. There we go. You can start to hear it. That would be 500 hertz. And you can still hear that annoying buzz in the background. If anyone has a suggestion on what else I can check or do to eliminate that buzz, I would love it. It's driving me absolutely crazy. But now that I verified that this direct conversion receiver is actually working, I can continue with my build. But I think what I want to do is connect it up to a half-wave dipole. I've built just a simple one out of speaker wire and PVC pipe, which I'm going to while my landlord's not around, we're renting. We're in an apartment here. I might just throw it up one evening so I can do some testing using on-air signals, and then I'll pull it down in the morning. So. So that's where I'm at right now. I would like to eventually put in a crystal filter. I've got a whole bunch of 10 megahertz crystals, so I'll mix to, this mixer will mix to 10 megahertz, so it'll have a 3 megahertz clock input, and mix the 7 megahertz up to 10, and then it'll be a crystal filter to filter, give me a lower sideband, and then I'll have another. What would that be? Another mixer. I'll probably need some amplifiers in there. I don't remember exactly what all is needed, but I'll have another mixer then to mix that signal down to the audio frequency. And then I'll have to build up the transmit chain, but I actually don't know what order I'm going to do things in. Now I can actually hear signals, so my thought is actually to maybe start building up the transmit side, and then I can get a more elegant receive side later. Although I guess for transmit, if I want to transmit single sideband, I'll need the crystal filter anyway. So anyway, I'm not really sure what order I'm going to do things in, but I am happy that this direct conversion receiver seems to be working out okay. So that's it for now. Thanks for your interest, and I'll catch up with you next time.